Hey guys, I thought I would share a video because there are a lot of things which are kind of helpful and getting repetitive. So here we are. I think most of the teams are doing great work. They have already built the hero bot and practicing driving and testing and getting frustrated, which is part of the process. But that's what the whole season is going to be about. So I'll share some of my thoughts on what are the key ingredients or the subsystems to build for this year's robot. Get some ideas, look into YouTube, look into what I'll be talking and sharing today. I think our first game is going to be October 15th. I set a score of 50 as a minimum. Let's see who can beat that score. Good luck. But so here is in general. I would I've been thinking about all the components required, and this is how I would start if and I've been telling you guys about draw it up, get the idea of how much score you can get with from your robot. Draw in as much detail as you can, and then it's easier to find the parts, or at least have an idea of what exactly is going to happen and how things are going to work. Blocks are need a system, or a part to exactly move from one place to the other. So a lot of things you can kind of get as a part of discussion with the team, drawing it up, get an idea on what exactly might work or not, and then actually you should start building. But I think most of the teams have something already in mind what they're going to build, and so I'll just share my thought process. I think this is one drawing of the robot. I would when I started thinking about, and this is not the picture initially I had in mind, but it as I started drawing, as I started drawing and building, I kind of got ideas and clarity on what exactly I'm trying to do. So one of the things which I wanted to tackle was the clearing the supply zone. So the robot has to move under the red bars there. So the design has to be low. And nothing on the robot which would block it from going inside. And then something in the front of the robot which can kind of flip and throw the blocks out of the supply zone. Initially, I thought it would be just drop the blocks on the field, but then later I thought, okay, why not have a bucket to collect those blocks, and if we have time, we can go in and drop those blocks also in the goals. And then so that was this bucket up here, which needs to be above the bar so that it doesn't block the robot from going inside. Then the bucket, and the other side for clearing the field itself. Most of the robots I've seen at Elevate is building some sort of a flywheel. Flywheel is a good mechanism. I think we tried a different. I have shown this in the past, a design which can also do an intake, but flywheel works fine. So I think let's stick with that. So there is a flywheel on the other end, for clearing the field itself. Flywheel, and then the bucket is in the middle. So the same bucket is used for storing the blocks which comes from the flywheel. Then bucket is over here, but our goal has a certain height, so the bucket needs to move up, and that's where the either arm comes, or the lift or the elevator comes, or one of the teams have built a lot of flywheels, and just like 6 or 7 of them stacked up, and that takes the blocks up to the level of the goal. But so all of those ideas are fine. I think just because of the space constraint and the length in my design, I thought it would be better to have an elevator. Might work too. And then so the elevator is something which can take the bucket up, and then either you have a choice, either you have on the bucket itself you have a flywheel to push the blocks out, or you have the bucket angled such that the blocks slide down. There is a gap from between the bucket and the robot, which is shown in this diagram, and you know you need to have a mechanism to kind of cover that up. Either a plastic sheet here or something of that sort might work. So you need to think through all of those options, like if you're building something, how far it is from the goal, how high it is, what is the height of the goal, what is the height of these blocks here, how high how long your drive train needs to be, how would you think about stability, and things of that sort, right? So just I think all of those were kind of the part of the thinking process. Then you kind of calculate what is the score you can achieve if you are able to maximum score you can get from this kind of a robot. And I come up with either you can focus either on purple or green, since it's a 1 minute game. You kind of add up all the points you can get. So the maximum this robot can do is either 92 or 102, depending on whether you're collecting green or purple. And then the additional 20 points you can get if there is a way to stack the blocks as they fall in the goal, which I don't have in this design itself, but it's a separate thing, one of the other features which can be added to the board, and separate mechanism, but that's the other thing. So things of that sort, you have to think through the game. You need to know the game itself. You need to have a drawing of as much detail. It can be one drawing or multiple drawings. Get to the point. This is not where I started from. I started from very different thing in my mind, but as I kind of started building and going through this process, and it changed over time. So this is what I have to show you. As I was sharing in the photograph earlier, this is the front flip mechanism. The base of the board is empty over here. There is nothing. It just basically is a flat long thing, and with the flipper in the front of it, so that you can kind of collect the blocks and then push them out. And then this is the drivetrain with, everybody has built a drivetrain by now, so you know what I'm talking about. There are two motors, and there is a brain. Brain is flat lying down, so not really sticking up to block. And there is nothing else up here in the middle. It's all empty. The other thing is, then I said, okay, let's look at the back of the robot. I mean, if this is the front of the robot, the back of the robot is the mechanism for the collecting the blocks on the field itself and clearing it. So this is the rubber band. I'm gonna need to order those and get it in. I couldn't find any right now, but the rubber bands would come here. Either I can focus on the greens, then the height of this needs to go down, this needs to be adjusted, or I was just focusing on the purple. So this is the height of the flywheel is going to determine whether you're pulling in green or purples. This doesn't have yet a support for decoding the color, but that can be, I don't think that is required, but it can be an additional thing to get a more score. Next thing up is the bucket in the middle, as I said, with the elevator up. So this is the bucket. Let me show you what exactly I'm talking about. So this is the bucket which goes up and down. Right now I don't have the motor attached, but you can see it. Even with the hands, motor is just going to speed up and give more power, but things should move with bare hands as well. and you should notice if there is any friction, if things are blocking, if there is something coming in the way. So that's the time to kind of fix those things, and then add a motor later on. This bucket itself is as you can see, this is the lowest point the buckets would go, leaving this entire space empty for getting inside the supply zone. I'll show you in a minute how exactly it would look like. The other thing after that is, yeah, so this is pretty much what I have in this robot. This has an elevator to move the bucket up and down. This is the way to move it up. The motor is going to be connected here. So this is one mechanism and this is pretty stable. I've added some frames in the back to kind of keep it in place. I have taken care of making sure everything is connected through these pins, properly secured. The one thing which is missing is, as you would be thinking about, okay, blocks come from here, but the bucket is over here. How does the block go from to this point? There, my thought is that there would be an extension of the bucket, which would be something like this, slanting down. Some of the pieces would be added here in the middle space up here, and you know, that would be something which would help the blocks get up here. Need to still test it out to see whether some adjustments of height and other things need to be made, but the frame and looks like some of the ideas have been tested, and so it should work. What else is there? I think the other, yeah, so this is the bot which has a flip mechanism for the clearing the supply zone, has a bucket mechanism, which one of our middle school teams is testing out. A similar idea, but they have designed it slightly differently, and then the flywheel in the back. Yeah, so let me show you how the robot moves. But before I do that, I think one other thing is, you know, how when I was building this, not that, you know, all the parts I would like to have or I had in mind were readily available, or so some of the things, for example, you know, this is, I think most of the time we are looking for a connector piece like this one, but it has you know, two sides, which is horizontal, versus something else which is an angled one, meaning this is the one piece which would let you connect perpendicular pieces, like, you know, going from top to bottom, like this. You know, easily you can use one of these, but if sometimes we don't find this, so the alternative to that is you connect it either, like, you connect a flat piece like this, instead of this angled one, you connect this one here, like horizontally, and then you put the pins in the middle, the blue ones, and then you use those to connect and go forward like this. So this does the same thing which the angled ones were doing, and that was mainly you know, it's similar, right? So you can go perpendicular even with the same direction connectors. Other than that, yeah, always make sure that there is a spacer in between the moving parts, like the gears, and yeah, and then just focus on when you're building something, focus on evenness that, you know, it should look identical. Everything should be pretty much, except the motors should be identical, connected at the same place. And if you yeah, so that's pretty much it, I think. So let me show you how this would move. I have not connected the brain and tested it or anything. This is more for an example for you guys to think about how to make changes, or how to build your robot, or you know, how to go about thinking process. So here I am. Let me, can I, okay, I need to, okay, let me see if you guys can see this. This is the bot. I think this is what I was talking about. This can go inside the supply zone, and this can go inside the supply zone like this. And the idea is that I need to still test it out with the, when it is moving at speed, when will it collect the blocks. Once it collects the blocks, this is going to push up, and then ideally the block should come over here. So, and then this can move back, and I mean, this is just a frame. I need to add a couple of things here to make sure the block stays in place. Once you have the blocks here, you can either dump it out on the floor, you know, clearing the supply zone, or if you have time, you can go in and drop in the bowls. The purple blocks are going to come in from here inside. You know, there will be a ramp here to get the blocks up into this this place in the bucket, and then you move up and drop. So this is just an idea of a robot. And then the other thing which I wanted to show you was the sizing of the bot itself. Let me show you what is the size of this robot. So if I keep it here like this, it is fitting nicely inside. Actually, there is some it can actually be extended more. You can see that there is some gap here. So this is meeting the height is this much, so this is under that height. This is the starting position of the robot. So the flip, this bucket is is fine if it is up here when you're doing the measurement. I can actually move this down and go a little bit more further out. That should give us a little bit more space for the blocks to come in. And then the height, and okay, so the other thing which I was thinking about when I was building was the measurement was one, and then the field itself was the other, and then the other was the height itself, whether the bot is able to is at the same height or not. So yeah, so it has sufficiently high. If you see from here, it is sufficiently higher than the goal itself, so it should work. And as far as the gap from here to there, that is concerned, I was thinking about putting a plastic sheet up here, such that it creates you know, the blocks don't fall, and if they fall on the plastic sheet, then they will slide down. Yeah, so just think through it. I think I will leave the robot on the table here. Just take a look, not just for getting some ideas on how the pieces are connected, how the bucket is, and the drivetrain is, and so on. The other thing which you need to kind of keep in mind is the number of motors. So I have 2 motors for the drivetrain, 1 motor for this flip, 1 motor would come here for the flywheel, 1 motor for moving the bucket up. So that's 4 5. I have one more motor. You need to think of the right use for that. Either it's the flipping for the bucket, it will come here, and then the inside of the bucket is detached from the frame, and that can go again, that can flip like this one is flipping, and then the frame itself is going to go up and down, um, and but the inside bucket is just sitting on inside the frame, so that also moves up, but can easily be flipped. Either that, or if we can kind of figure out a way to make this slant, the bucket itself is slanting, that through some sort of pieces up here, which is connected like this, connected like this, then the blocks would, when it moves up, then we can kind of have it slide down. So then we don't need a motor there. We have one more motor. I think that I'm saving that. In that case, if we don't use it here, then we have one more motor. I'm saving that for the stacking up of the stacking of the blocks. I think there is a mechanism I have in mind, which should work, but you need to, even if it works, and you kind of think through how to make it work for your robot. Just take a look, see. I think if you're working on a different design, you can see this for how the parts are used, and things of that sort. And yeah, so all right, I'm looking forward for seeing what you guys can come up with. I think unique designs, there is nothing right or wrong. You can make anything work. That's the beauty of it. It's just, as long as you're making sure that the dimensions are met, it does the task which you're intending to do. It's not going too heavy or too like uneven on different sides. So yeah, that's the other thing which I would like to share. I did notice where the buckets are connected, not the buckets, the motors are connected, the brain is. So I think this is pretty, like, kind of a stable robot. I can, like, I'm not seeing it very flimsy or too heavy, or things are falling, or or too much space for blocks to get stuck and other things. I mean, there are a few additions to be made. It's not fully done, but it's pretty much I think the structure is there. It's an incremental change from this point, when you start testing and figure out the sizes of the blocks and other things. So yeah, I think that's it. So just stay on the course what you're doing. If you have no idea about what would be your next step, think of what you have done so far, like built an arm or built a hero bot. Read the game manual again, please. You need to be familiar with what exactly are we doing, unless you just started. We have gone through the basic drivetrains, building arm, building claw, building a hero bite, testing it out. We should all know what the scoring mechanism is, and we haven't gone into the coding part yet, because coding would come is very dependent on, I mean, everybody has a starting point of the coding, but that actually works by default. Coding would come once you have a bot, and it will be very specific for what exactly you want to achieve. So we'll cover that on as you make progress, but there has to be so in the teamwork challenge, and the skills challenge, there are 2 rounds would be covered with where if you build a robot, you can actually go in and compete and start the competitions without actually having to go play the autonomous round. What else I want to cover? So yeah, so October 15th, have start, I think this week when you are coming in, spend some time refining your bot, at least get to the state where it is, it's working, it can, and you have a mechanisms to kind of even collect few blocks, or at least have something in a working state, get to that point. uh, if you are far ahead than that, then that's awesome. I think it's still early in the season, so we do have October and November. December 2nd is our first competition, so we need to be ready by then. So yeah, keep building, keep experimenting. No idea is a bad idea. It can, you can make it work. If you find a flaw, or things are not easy, there is no there is no, you have to, test it out. There's no, like, answer to it. We're here to help, and give guidance, give ideas. You have to try it out and spend time and note down all the issues you're observing and go attack one by one. um, Pick up the easy ones first. Like if it is not stable, then how do you add stability, and so on. So yeah, so happy building. I hope I covered some of your um, um, kind of next steps, or helped in the thinking process a little bit. Yeah, so yeah, just keep doing what you're doing. I think you're all doing awesome. You're all making good progress. Working as a team is not easy. And yeah, just good luck, and yeah, so hope to see some crazy robots coming out. All right then, thank you.